what we're interested in when we're doing philosophy of science is trying to get at what scientific knowledge is and what it tells us about the world.
Some level what's at stake is pretty much all the stories we tell as to the point of doing basic science.
It's really, I think, one of the most fundamental debates you could have. It's about what does science tell us? Does it just tell us about itself and how we understand, for example, the things that we can see and move and touch, or does it tell us something deeper about how the world is?
It's about the relationship between science and truth.
What we're doing in our scientific theories is learning deep truths about the world that we wouldn't otherwise have discovered. When we spend billions of dollars to build particle accelerators, we're not just doing that because we like pretty patterns on the particle detectors. We're doing it because we really are finding out about the world on incredibly short length scales.
What I want to do in these lectures is to convey my fascination in some core issues in philosophy of science. Science is a thing that we really ought to stop and think about every now and then. It's a wonderful source of knowledge, gives us all this amazing technology, and philosophy of science helps us to think about what science is, how science relates to reality, and what to make of it. The topic for the lectures is this notion of scientific realism. As the opening clip indicated, this is a debate about scientific truth, scientific knowledge, and what science tells us about reality. Now, just a while ago, there was a challenge on Twitter to express in 6 words or less what your topic of research is. And I said about scientific realism that it's this, scientific knowledge. Is it for real? Guess how many likes I got? 1. Just 1 like. It's unsurprising. I mean, it's a silly thing to say. Is scientific knowledge for real? Of course, scientific knowledge is for real. But let me try and convince you that there's a serious question behind that. There are serious issues that we ought to think about in relation to scientific knowledge and reality, and whether or not scientific knowledge really captures something for real. It'll take me more than 6 words to do that, so let's get started with the following idea. So the first thing to appreciate in thinking about scientific realism is the magic of science. Magic of science is something that is absolutely all around us. It's in our pockets. So here's a bit of magic of science. I went to Japan last month and able to pick up my phone and FaceTime with my son in real time to show him what it's like. The screen of my phone displays a million different colors. It has close to 3 million little pixels. That's amazing. Just stop and think about it, how magical it is that we have handheld devices like this. Now, to really get to the quote here, this idea that any sufficiently advanced technology is indistinguishable from magic, just imagine showing a device like this to, say, Isaac Newton, a leader in the science of light in the 17th century. For Newton, this would be utterly indistinguishable from magic. Now, of course, one of the things science has taught us, one of the ways in which science has transformed our lives, is that we don't believe in magic. So when we think about the success of science and how science has transformed our lives in a matter of a couple of decades or actually a couple of generations, we should be struck by this question: how can science be so incredibly successful? What's the naturalistic answer to that question? There ought to be one. We don't believe in magic. Now, what do you think? What is the answer to that? There's a very natural answer that many people have thought is the only answer, which is the following. Surely science is successful by virtue of scientific theories being good representations of the way the world is. There's no amazing coincidence that all of you ended up in this lecture to hear my talk. You have a mental representation of how the world is, where things are located, what's happening, and when. That explains why you are here. In a broadly similar way, scientists have good representations, the thought is, of electrons and semiconductors and so on, and that explains why science can be so successful. To my mind, scientific realism is all about this idea. What are the limits of that sort of explanation of the success of science? How far is it right? What are its limits? That's what the scientific realism debate is, for me, all about. So in this first lecture, what I want to do, I want to give you some background to these debates about scientific realism. I want to lay the ground for further discussion about that question in relation to physics of light that I'll talk about in the next 2 lectures. Today, what I want to do is to be very clear about the key questions for us to keep in mind throughout these lectures. And then I want to reflect on what the philosopher's role is in answering these questions, what the philosophy or the philosopher can contribute in answering these questions. And I want to give you a sense of progress in philosophy of science in thinking about these issues by way of thinking about some very traditional skeptical ideas about science and how debate around those ideas has grown stale and how we can do better. Now, science, of course, is magical, not just in the technological sense of providing nice phones and so on. It's also quite magical as a source of knowledge. I'm sure all of us are scientific realists to one extent or another. We use science to guide our beliefs, what we believe or take to be true about the world. There's one thing that one ought to emphasize whenever we talk about skepticism about science, and it's the following. There are no grounds whatsoever to deny the idea that science has made great progress in providing us knowledge. No one in this debate on scientific realism denies that. We all take it for granted that scientific knowledge has grown. Everybody agrees that scientific knowledge has even grown exponentially. If I look into Wikipedia, for example, for a timeline of major scientific discoveries, or perhaps I ask my phone, Siri, can you tell me what the major scientific discoveries have been? I get a list like this. And everybody agrees that this list is on the money. Scientific knowledge has grown in such a dramatic way. Around 1500, we didn't even know that the Earth revolves around the sun and the Earth is not the center of the universe. Just over 100 years ago, we didn't know that the continents move. We didn't know that the universe is expanding. We didn't know that our galaxy isn't the only galaxy. Now we know that there are billions of galaxies out there, and so on. Having said that, putting things like this can be misleading as well. If we zoom in on the latter part of this list, when it comes to modern science, modern physics, in this list culminating to the discovery of the Higgs boson, is it the case that these scientific discoveries are entirely on a par with the scientific discoveries that came earlier on? Should we take, for example, the discovery of the Higgs boson to be on a par as an item of knowledge with the discovery that the Earth is revolving around the sun? Or are there differences in how we ought to think of progress of scientific knowledge earlier on and later on? I think that, for me, is one of the key issues here. How should we best appreciate contemporary science, the kind of progress and the kind of discoveries it makes? So just to zoom in, for example, on this justifiably celebrated discovery of the Higgs boson, the way it's been reported, for example, in the annual report of CERN is as an experimental detection of the Higgs boson that was predicted 50 years earlier by Higgs and Engler. The way it's been reported is very much as an item of knowledge that is on a par with these discoveries about, for example, that continents move or that the Earth is revolving around the sun. When we are confronted with these advances in contemporary science over the past 100 years, I think there are key questions that we ought to think about. What kind of progress does physics make? Is the sort of theoretical progress made by physics primarily a matter of accumulation of knowledge? What kind of knowledge does physics provide? And these are the questions that I'd like you to keep in mind throughout these lectures. These are the questions that we want to be thinking about. When it comes to reporting the advances of modern science, it's often reported as a matter of increasing knowledge. That's how, for example, CERN reports its business, what they are doing. The research at CERN is at the forefront of human knowledge. Its business is fundamental physics, finding out about what the universe is made of and how it works. It's very much like finding out about the continents and how they move, finding out about planets revolving around the sun. But I think we want to ask these questions. Exactly what kind of knowledge do we get from fundamental physics? In exactly what sense should we trust the kinds of theories that are tested, say, at CERN? Now, what's the philosopher's role in answering these kinds of questions? There's a very good reaction you might have when I presented the key questions to you. You might be wondering, I think you should be wondering, exactly what can the philosopher provide in answering these questions? What can this guy, what can I, as a philosopher, provide on top of the scientists? Why don't we go and ask the physicists who are producing the knowledge in physics what kind of knowledge they think they are providing, what kind of progress they are making in their science? What can the philosopher provide? Now, of course, in the course of these lectures, I hope to demonstrate that there's a lot a philosopher can provide. I hope you'll appreciate that the spirit of this endeavor is not in any kind of antagonistic opposition to science, but rather in a way that's meant to be continuous with science. The way I see philosophy of science answering these kinds of questions about scientific knowledge is naturalistic in the following sense. I think philosophy of science ought to be complementing and supplementing scientific answers to these questions. It's not questioning science from without science. It's rather working with science and building on science in trying to answer these questions. Some people call it naturalistic philosophy. It's also called second philosophy, in opposition to this idea that philosophy might begin with some philosophical first principles that we can know totally independently of any scientific research. So the way I see it, when we are looking at these questions, we are really, in a way, cherishing the role of science. Now, what do you think is the best way to cherish the role of science? The role of science in shaping our worldviews, giving us all this knowledge. What's the best way to cherish that? I think the only way to cherish that role of science is a critical one. That's the only scientifically respectable attitude towards science. Richard Feynman beautifully put it. In science, we have this freedom to doubt. We are permitted to question, to not be sure. And I see philosophers of science in these debates about skepticism, about scientific knowledge, just doing that same thing. We are just taking the same critical attitude towards science that scientists themselves take towards some long-held beliefs about how the world works. Just in the same business. Okay, so I've given you a sense of what the questions are and what the spirit of this enterprise is, how I see philosophy of science approaching those questions. Now, for the rest of this lecture, I want to talk about 4 sources of skepticism that one might have about scientific knowledge. And I want to indicate how debate about those ideas has grown stale, and that will then point towards ways of doing things in a way that is fresher and hopefully more engaging. The first source of skepticism that I want to talk about goes back to the start of modern philosophy, all the way back to Descartes. We'll talk about Descartes next week in connection with Descartes' scientific ideas about light and rainbows. For now, I just want to remind you of Descartes' great philosophical idea. Well, Descartes took science very, very seriously when he was thinking about what he could doubt, what the limits of his knowledge are. He came to realize that, in principle, he could doubt most things. He could doubt even the existence of external reality, reality external to his mind. Various kinds of modern reincarnations of that idea. One possibility is that we live in a computer simulation. You could doubt the reality of the external reality on that basis. Now, is that a kind of skepticism about science that we ought to seriously engage with or entertain in relation to scientific knowledge? Well, I think not. It's not something that philosophers of science get very excited about. The reason should be quite obvious. Skepticism of that sort doesn't really engage with science in any way. It's not really about scientific evidence or science per se at all. It's a much, much more general sort of skepticism about knowledge. The reason I wanted to highlight this kind of skeptical idea is that it's a paradigmatic example of what we ought not to do. It's kind of unnaturalistic philosophical skepticism based on philosophical first principles about knowledge. In the case of Descartes, a certain kind of foundationalism about knowledge. That's not the kind of skepticism that we ought to engage. The second idea about skepticism in science is based on this idea of undetermination. And the key idea is quite simple. So when it comes to empirical sciences, empirical theories are based on data, some empirical evidence. There are good questions about how the data relates to theories. What is the relationship between the two? And philosophers of science have written a lot about that. Now, one thing seems clear. The data is never sufficient to logically entail the theory. There's always room, as far as the logic or mathematics of it is concerned, for the possibility that some other theory is right and accommodates the data just the same. Now, many philosophers have thought that maybe that idea should make us skeptical about any theory we have. How do we know that we have the right theory, given that it's logically possible to have these other theories that make the same predictions? So just as a quick illustration of this, consider kind of a classic curve-fitting scenario. You have some data points, and as far as the mathematics of it is concerned, there are infinitely many curves you can draw that capture all the data points. Of course, there's also some measurement errors. There can be some noise. So there are further questions about how do we get the best balance between not underfitting our theory to the data and not overfitting it. And those decisions are dependent on background beliefs, how simple we think the theory ought to be. So the undetermination, again, crops up as the possibility of changing your background beliefs and getting a different theory, hitting the best fit between the data and what we'd expect. Now, these kinds of issues about undetermination and model selection are serious challenges in specific scientific context. But can we get some kind of general skeptical argument about science out of this idea of undetermination? No, it seems not. It seems that if one takes this idea that the mere possibility of some other theory being correct, that captures all the data, if one takes that idea that seriously, then one ends up adopting something like radical skepticism of Descartes. There's no difference really in the kind of scenario that convinced Descartes when he was thinking about, for example, an evil demon manipulating his thoughts so that everything looked like the external world was out there. And a scientific case where you have all the scientific data and you are just thinking about the possibility of some other theory getting all the same data right, but not saying what your theory says. It's not clear why we shouldn't trust good scientific judgments about what we take the evidence to confirm. Now, the third idea that has been very influential in the history of philosophy of science is empiricism. It's this idea that when it comes to knowledge, empirical knowledge begins by observing the world by the naked eye. Then there's a difference between things you can see by the naked eye and things that you can only see by making a theoretical inference from what you can see to that thing. Many philosophers have thought that maybe that distinction is so profound when it comes to knowledge that we really ought to be skeptical about anything that we can't see by the naked eye. Somehow this idea is that seeing is believing, that sort of idea. So for example, there's a clear difference in the following two kinds of inferences. You can make an inference from what you see on the night sky, this trail of fire and smoke. There's a piece of rock traveling at a very, very high velocity, causing that. In the other case, you can make an inference that you have a particle in a cloud chamber, in a particle accelerator, giving rise to these nice patterns. But there's a fundamental difference in that the rock you could see if you were close enough. We are familiar with rocks and the kinds of objects that we are making an inference about. But none of us has ever seen or will ever see a particle. Possibly, the thought is, the inference here is to an object that might be just a theoretical construct and not a piece of reality in the way the rock is. Now, that's the idea. How seriously should we take this kind of skepticism about science? Now again, I think philosophy of science community is moving away from the idea that somehow this kind of distinction between what we can see by the naked eye and what we can't is somehow fundamental to science. The reason is that you can't find in science anything that really correlates to that distinction. If you take the idea of seeing something by the naked eye too seriously, then you end up only believing things you've actually seen. And you can't even accommodate knowledge about the future because none of us have seen the future. You can't accommodate knowledge about the center of the Earth because none of us can really see the center of the Earth in any realistic way. We can't accommodate knowledge about stars and galaxies outside our light cone, even though they are rather big. So as far as science goes, it seems that the distinction between good inferences and bad inferences just doesn't at all align with this distinction between inferences that take you from observable things to observable things versus inferences that take you from observable things to things that are unobservable by the naked eye. Now, the fourth and final source of skepticism about science that's been very influential in philosophy of science turns on history of science. And here the idea is that if you look at the history of science, you can see all kinds of sophisticated theories from Ptolemaic astronomy to phlogiston theory of chemistry to various ether theories of electricity and magnetism, theories that can be very sophisticated and mathematically very refined, and theories that can be very successful in making new predictions and in explaining various kinds of phenomena. But theories that are simply false, it seems. There is no ether, there is no phlogiston, and the Earth certainly isn't at the center of the solar system. So the thought is, you can have successful theories that are clearly false. Scientists have been wrong many, many times. So maybe in the fullness of time, the same pattern will repeat. Maybe in the fullness of time, we'll see how scientific theories that we currently hold dear will again go, and some other theories will take their place. Now, what should we make of this idea? Should we take this as a serious source of skepticism about science at large? There are various things that are wrong, I think, with this line of thought. For one thing, as far as our scientific understanding of good inductive inferences go, these are inferences that take a sample and then project to some broader regularity. The kind of pessimistic induction that you can try and get from the history of science seems like a really, really bad or weak induction. It's not a good inductive argument at all as far as our scientific understanding of strong inductions is concerned. Secondly, as many philosophers have pointed out, this idea that there's accumulation of knowledge in science and progress in science is completely compatible with scientific theories also exhibiting radical changes in the history of science. There are good questions about exactly what the sense of retention and progress is. But the two aren't really incompatible in any fundamental way. Relatedly, there's something fundamentally wrong-headed, it seems, with this idea that this kind of pessimistic induction takes the strength of science in a way and tries to turn it into science's weakness. You see, the strength of science is that science is able to find the shortcomings of its theories and correct those. So what you would expect is that if you start with a scientific theory that is sufficiently far off the mark, then the scientific process of finding out what's wrong with that theory and correcting it should lead you to expect the kind of historical pattern of radical changes that we have in the history of science. So, as an analogy, you wouldn't really argue for any sort of skepticism about contemporary cartography of the British Isles by pointing to the fact that if you look at the old Roman maps of the British Isles, they are in many ways radically wrong about the landscape, and they exhibit radical changes from one another. That's what you would expect. You would expect, given the difficulties of early cartography, that if you begin with a point that is sufficiently far off the mark, the processes of finding out what's wrong and correcting those will show a historical record like this. Now, abstracting away from some of the details I've talked about, there's a kind of a general lesson that we can draw here. We can try and diagnose why debate around these kinds of ideas has grown stale in philosophy of science. There's no great progress in philosophy of science regarding the four ideas that I've talked about as general sources of skepticism about scientific theories and scientific knowledge. And the issue is that these arguments seem overly general in two ways. They either are in tension with our scientific perspective on what human knowledge is and what its limits are. In tension in adopting some sort of philosophical first principle, as in the case of naked eye observability being somehow critical for what can be known, or in the case of Descartes' radical skepticism. Or they inflate the significance of the kind of evidence that is presented for skepticism about science. So the historical evidence, for example, that really does indicate that we should not take our current scientific theories at face value, and we can see that successful theories can be in many ways wrong. They take evidence of that sort and they overinflate that to a very general, very broad-ranging conclusion that goes well beyond what the evidence really shows. So from a naturalistic perspective on science, these kinds of very broad skeptical arguments simply aren't convincing at all. And I think that's the reason why philosophical debate about these skeptical arguments has really grown stale. There's little room for any kind of productive scientific engagement with philosophy if we are thinking about skeptical arguments in these ways. And I think this points to ways of doing philosophy of science better, doing philosophy of science in ways that are more productive for interesting engagement between philosophy and science. And I think the key idea is that philosophical engagement with science should turn on evidence that is scientifically respectable. It should not turn on philosophical first principles that, to a scientific mind, have no evidential value, just seem philosophical first principles. And I'll go on to explain in the next lecture how such evidence can be found in the history of science and in the theoretical foundations of specific scientific disciplines. I think there's a seed of truth to the kinds of skeptical arguments that I've briefly covered, but we have to think of that sort of evidence in play in a much more case-specific way. The guiding idea for how I'm thinking about the productive engagements between philosophy of science and science itself in a way that makes philosophy of science continuous with science is based on this idea that everybody in this debate, everybody who's interested in knowledge and, for example, what light is and what we know about light, accepts this basic principle of total evidence. When we try and answer a question about light, for example, we should take into account all evidence that bears on the question. All admissible evidence is valuable. The more evidence, the better. And thinking about the debate in that way gives a role to the philosopher, in as far as the philosopher can bring to light further evidence, evidence that the scientists can't see, and then help to synthesize that evidence with the scientific evidence that the scientists are dealing with. That's how I'm thinking about the productive interaction between science and philosophy here. Just to give you a very quick example of how evidence functions in this way. Now think of you, for example, asking for my name. What's your name? I say, my name is Juha. That's good evidence for you to believe that my name is Juha. You could stop there. You could say, now I know his name. I have the evidence. The testimony is enough. Or you could step back and you can ask a further question. Imagine that you find out that I'm a compulsive liar. That further evidence would undermine or undercut the evidence that you first received. Now imagine that you hear yet another piece of information about me. I'm a compulsive liar, but there's one thing that I've never lied about, and that's my name. Now that further information would again interact in an interesting way with the second piece of information, restoring the evidence that you first received. I'm thinking philosophy as providing evidence that interacts with the scientific evidence in those interesting ways. But of course, the evidence will be much more case-specific. It will not underwrite any kind of broad, overarching skepticism about science in the way the kind of skeptical arguments that I've talked about have tried to do. Now, the best way to show you how it works is to actually do some philosophy of science in this spirit in relation to a specific area of science. And that's what I'll be doing in the next lecture in relation to physics of light. For now, let me just conclude with a simple 4-step recipe for doing philosophy of science in this area in a productive way. We start with this idea that science is quite magical. We recognize the magic of science all around us. And we recognize that magic of science is something that really needs an explanation. Secondly, we realize that depending on the explanation we provide, the way we understand scientific knowledge and the way we understand scientific progress is going to come out different. If we provide a realist answer to the question of how science can be successful in terms of this idea that scientific theories are excellent representations of reality, that's going to lead to one answer to how we understand the limits of our knowledge and the nature of scientific progress. If we think that the right answer, the right explanation, to the question of how science can be so successful is just that scientific theories are powerful instruments, for example, without them representing reality, then that's going to have repercussions, radical repercussions, on how we think about scientific knowledge and progress. In trying to answer these questions, we ought to adopt a critical attitude towards science, the Feynman attitude, the same attitude that scientists themselves adopt towards the world. We shouldn't take as gospel just what the scientists say. We should ask for evidence. And we should look for further evidence, the possibility of there being further evidence that is scientifically respectable and contributes to the total evidence that bears on the questions that we are interested in. So next week, as promised, I'll be doing that in relation to science of light. I'll be looking at the advances over centuries in scientific understanding of the rainbow. And I'll be looking for evidence that speaks to this question, what is light? There's scientific evidence, of course, in play. There's scientific evidence for certain theoretical representations of light as a certain kind of wave motion of electromagnetic fields. What I hope to show is that on top of the scientific evidence that speaks in favor of these kinds of representations, there's evidence from the history of science and from the foundations of optics that contribute to the total evidence in how we ought to think about the question, what light is. Okay, that's what we'll do next week. For now, thank you.